So a very bold title, I hope to explain to you. I hope my presentation lives up to why that is. So today we're going to take you on an adventure. We have the privilege of traveling to the deep sea floor aboard Alvin, one of the most celebrated research submersibles in history. Alvin was the HOV to bring scientists face to face with the wreck of the Titanic for the first time. And it's one of the only submersibles capable of traveling deeper than 1,000 meters, which, as Samantha mentioned, is something that we need to explore, these ecosystems. Today, Alvin is taking us on a tour of 8 very special sites within the Southern California borderland, the area that goes from Point Conception in the north to the US San Diego border in the south. An underwater landscape that's been torn by millions of years of tectonic activity into deep basins and steep ridges. As we descend into darkness, past the euphotic zone, we leave the layers of the ocean where photosynthesis drives the largest food web on Earth. Every fish, every whale, every creature associated with the ocean ultimately depends on sunlight. However, as we go deeper, that source disappears. And you see a layer of water where microbial feeding frenzy occurs, burning through oxygen as they decompose the organic material. As Alvin's lights come on, you see now, well, we've already went through the plumes. These are actual videos from Alvin and pictures from HOV Hercules of the 8 sites of Southern California. You'll see these bright patches, clam beds, a variety of different microhabitats that are all unexpected to most. You'd expect to see a barren, muddy sea land, but that's not the case in these ecosystems. The seafloor is no longer uniform. It has texture, it has structure, it has neighborhoods. Life in the middle of an otherwise severe seafloor, barren seafloor, thriving in spite of conditions most would consider inhospitable for life to exist. There's no sunlight, almost no oxygen, and a toxic gas leaking through the seafloor. What you've just observed are the magical and mysterious methane seeps of Southern California, one of the most fascinating, productive, and overlooked marine ecosystems on the planet, and the powerhouse making all of this possible, the mighty microbe. Everything that you are seeing is made possible by very specialized microorganisms, invisible lifelines that most don't even know exist. These superheroes filter out 90% of the toxic methane before it even can leave the seafloor sediment. They form the base of an entirely new food web. They sequester carbon and support thriving communities of foundation-building species. They've been found to be habitat to commercially valuable fish and are being revealed to host a significant number of new and unidentified species, which, in just a moment, will lead to my problem statement. Most people don't know that these exist. Methane seeps are Earth's invisible life support system, but they're largely unmapped, unmonitored, and unknown. So why should you care about this? Why should I care about it? Well, so as we're finishing this, I'll go into, has it replayed maybe? Shouldn't still be, okay, we'll go here. So why am I? So for a second, I wanna get a little personal. As Samantha mentioned, I did come from a background in finance. In particular, I studied commodities, so oil and gas, metals, and mining. Like others here, somewhere along the way, I became a scuba diver. And for me, it was at a point in my life where I had just lost somebody very special to me and was really struggling. And when I discovered diving, it was completely transformational to me. My first time beneath the surface, it's like healing and happy and everything that I wanted. Life, everything changed, my perspective changed. And so in commodities, I spent a lot of time following a lot of natural earth disasters. I followed commodities on a daily basis. So years of watching what happens when natural resource decisions get made too fast with too little science and too little regard for what might be lost. Situations that environmentalists and conservationists try to avoid through the precautionary principle. While this term came about more in the 70s, it really became famous in the 1992 United Nations Earth Summit. It's a concept that not only supports not taking actions that could harm the environment without adequate science to understand the impacts, but also shifts the burden of proof to those seeking to take action and not the conservationists fighting to protect it. How is that relevant to my project? Well, these ecosystems are extremely sensitive to sediment disturbance and increases in methane flux caused by human disturbance, vis-a-vis seabed mining, seafloor trawling, and increased momentum toward, offshore oil and gas, and increased momentum toward seabed mining and hydrate gas extraction. As we all know, marine science, climate science is going through an extremely challenging time when our current administration, major defunding and deregulation, elimination of environmental protections, the repeal of the endangerment finding of greenhouse gases. That perspective shaped everything, how I approached this project and what I wanted to accomplish. And as many of my members of my cohort know, this is a topic that's very deeply personal to me. Try to get through this without any tears. Oops, here we go. So the project was, I got through that. So the problem is that nobody knows what methane seeps are. How can they protect something they don't know about? So the goal is to elevate the profile of methane seeps, to raise awareness so that policymakers, fisheries planning, the average person, scientists who don't study the deep ocean know they exist, so therefore they can actually start to do something about it. So this is what my project is about. So do you know what a methane seep is? Most people don't, so I'm just going to tell you really fast. Methane seeps are one of the most important marine ecosystems discovered when our friend Alvin took a geologist and oceanographer Charles Paul to the seafloor of a Florida escarpment in the Gulf of Mexico. These are not rare ecosystems by any means. They exist in the thousands, and even in Antarctica. Deep within the Earth's crust, vast pockets of highly pressurized methane gas are currently leaking, trying to make their way out of the atmosphere by migrating up through the seafloor. The greenhouse gas has warming power 80% higher than CO2. Methane seeps form when the Earth's geology creates both a source and a pathway for hydrocarbon-rich fluids, mostly methane, to travel towards the seafloor. Organic matter, dead plankton, fecal pellets, etc. Over millions of years, the buried organic material is converted into methane, and under intense pressure and temperature, or by bacterial producing it, as a metabolic product of what they consume, the organic matter. In Southern California, this organic matter accumulates and gets buried very quickly because of the deep basins that I mentioned. Strong coastal upwelling drives surface productivity, increasing the amount of organic material that gets trapped in these basins. And the pathway, high amounts of tectonic activity in California, especially here in Southern California through the San Diego Trough Fault Zone, that gas gets squeezed up to the surface. So now, rather than walk you through a bunch of slides with a lot of text, I'm going to do a website demo for you, methaneseeps.com. As you just, big surprise, when I sought the name, it was available. So here we are, building the greatest website you never knew that you needed. At the foundation, so first, when I sought to build the website, the first questions were, what are methane seeps? Why are they important? What are the threats that they face? Why are they called biodiversity hotspots? How do they matter for policy and fisheries management? And what kind of research could people look at? So here, I had never built a website before, so bear with me on the sizing and everything. But so this on the homepage we land, it shows the regional spotlight. So we chose to focus on the 8 seeps of Southern California, and each of these little boxes takes you to the specific area of the website. So for example, Southern California Regional Spotlight, I did kind of just walk you through those 8 seeps, so I'll get started on how they are serious servicers, which is the next tab. So first, they are a climate filter, like I mentioned. Research estimates the microbial communities at seeps consume somewhere between 70 and 90% of rising methane. Second, they are the engine of an entirely new kind of food web. The hydrogen sulfide that microbes produce as a byproduct becomes fuel for sulfide oxidating bacteria, which power chemosynthesis. Not photosynthesis, no sunlight, pure chemistry turning toxic gas into organic matter in food. And animals evolved to play directly into that engine. Chemosynthesis clams form sulfide oxidizing bacteria inside of their own gill tissue. Vestimentiferan tube worms have no mouth, no gut, and they have bacteria inside of them that provides their nutrition. These tube worms can live for hundreds of years. And one other aspect, so we see it on here that I forgot to mention about the microbes, is that they also form, as a process of when they're oxidizing methane, they actually form carbonate structures. And those carbonate structures end up being, let me see, let me pause this, oh gosh, what did I do now? Well, okay, I guess we're not gonna see my website demo anymore because don't bear with me. We won't go through it again. But so the carbonate structures that are formed by the methane, by the bacteria, form structures that all these other foundation building species can then, like that you saw in the videos, like the tube worms, clam beds, bacteria mats of these mighty microbes. And then those different microhabitats and those foundation building species, the microhabitats are created by foundation building species, and then larger species have come, and these sites have been known to be home to commercially valuable fish. Scientists don't exactly understand why yet, but they are. That's something that needs to be studied more. The threats, as I mentioned before, really is seafloor mining, oil and gas extraction, and any other human disturbance that can disturb the seafloor. So my process, just real quick, just to go through it, most importantly, we had a multidisciplinary group of people who were helping me brainstorm and help me learn throughout the way. The focus for the website, I definitely want to have a lot of interactive media. We're very fortunate to have access to thousands of hours of videos and photos that were taken from Alvin and other submersibles. And then a research portal on the website, which links for those who are so inclined to all the scientific papers and academic research. But the majority of the website is focused on just being very accessible for non-scientists. So the conclusion, to go back to the precautionary principle, we do not want to wait for another Amazon rainforest destruction. We do not want to wait for another Deepwater Horizon causing damage to our precious oceans. We want to take action before it's too late. And so these are just some actionable ways that people can get involved. I know policymakers, fishermen care. Fisheries planning is very, very important, and the fishermen keep our fisheries sustainable. Everybody wants to work together, but the enemy here is a lack of awareness. And I seek to change that with this website. And with that, I'd like to thank you, and always remember the mighty microbe. And I'd really like to give a huge thank you to my entire capstone committee, especially Dr. Lisa Levin, who definitely, when I came here, I didn't know anything about the deep ocean. I expected to be in the water every day diving, but I knew I was really cared about trying to protect it and do my part. I didn't know what that looked like, but I may not be a mighty microbe, but like everybody else, we can all be superheroes and do our part to protect the ocean. My other members of my committee, Dr. Gregory Rouse, Dr. Susanna Liedstrom, and Dr. Natalie Hilme, and then everybody else in the Levin Lab who helped me as I was learning along the way. Dr. Jillian Maloney, so I didn't mention it here, but actually one of the most recent methane seep that was discovered is right off Anacapa Island, only at a depth of about 80 meters deep. Still beyond recreational diving, but it's really, really interesting. Special acknowledgement to my cohort, Hannah, Samantha, and all of the photo credits in this go out to those who funded the research cruises. They are desperately needing additional funding. I would love more funding to continue this site. The site seeks to be more global in nature. Right now, it just focuses on the 8 seeps of Southern California. But over time, we'd like to change that. And with that, I'll take questions.
And I think we have time for maybe just one question, if anyone has one. Jen, thank you so much. This was really amazing, and you've been so passionate about this from the start. So I would really love to hear about what the most meaningful part of this project was to you.
All of it. I would say the most special time that I had was the opportunity to be in Dr. Levin's lab, learning from her. She's a legend in deep ocean research. When I was studying, trying to learn what methane seeps were myself, I was watching YouTube videos about different research cruises along, Chilean margin. And I didn't even know that Dr. Levin was on this trip. And all of a sudden I hear her voice in the background. Of course she's on that boat because she knows everything. So having that opportunity, being able to view all of the film and pictures. These are places that no human eyes will see unless you're in a submersible or ROV. So that was really, really special. So that opportunity to learn from Dr. Levin and the rest of my committee and everyone else was really special.